All right, AP test is really split into two sections, the multiple choice section and the free response section. We've just gone over the multiple choice section. You took a practice multiple choice test. Well, that's half of your overall AP grade. Okay? All of those questions, the 28 no calculator questions, the 19 calculator questions, that is worth half of your score. The next half is the free response half. You'll have 2 questions with a calculator. You'll have 4 questions without a calculator. Okay? All you do to find your overall score is you take your average of these 2 averages. That's it. You got a 60 on the multiple choice part, but you got a 70% on the free response part. You end up with a 65. If you're lucky, you get a 5 if that's the cutoff. Okay? If you get a 50 on the free response, you get a 70 on the multiple choice, well, you get a 60 as your overall grade. You get a 4. Okay? It's that simple. Each part is worth the same amount. What people freak out about is this. They see 28 questions, 19 questions. If I don't know one question, that's going to be okay. There's enough questions that I can, overall figure things out. But here, we got 2 questions and then 4 questions. 6 total questions. Now, the questions aren't just one question. There's multiple parts. We've done free response questions before. Okay? Each question has a total possible point value of 9 points. Don't ask me why they chose 9. But, for the 9 points each, 6 points, 6 questions, 54 possible points. Okay? That's the free response. Now, everybody freaks out. 6 questions. But what you will find, especially after looking over the last 10 years of free response questions, which you will be doing either in class or for homework, is that the types of questions asked every year are very, very consistent. And once you realize, oh, I'm probably going to see this type of problem, this type of problem, this type of problem, and this type of problem, you will feel less unsure and scared about this portion of the test. So I've done this analysis, and I put it up on the board. Of the last 6 years of the types of problems that are asked. And what I found, and if we are starting at 2013, but I added 2014 to the left of it, is that if you look at 2013 number 5, so you flip through, you go to 2013 number 5. That's an area/volume problem. Area between curves, spun around an axis, volumes of known cross-section. Well, if you look at 2012 number 2, guess what? Same type of question. 2011 number 3, guess what? Same type of question. What you will find, and what I found, is that over the last 10 years, there's always been an area/volume problem. So guess what? Prepare yourself for that type of problem. It's probably going to be on your AP test. What else can you find? Well, there's a differential equation almost every year. 5 out of the 6 years, there have been a differential equation, a Unit 9 type problem. Almost every single year, there have been problems where you're just given a table and you're asked to find certain things using Riemann sums to, the fundamental. There's always a problem like that. There are always problems where you're given either the graph of f prime or you're given the accumulation function and you need to work through those. Okay? What we will be doing is, since we know these 4 units there is a AP free response problem for those 4 units. We're just going to worry about 2 units at a time. We're going to worry about these 2 units at a time. We'll then worry about these 2 units. And then if we are comfortable with those 4 types of problems, out of the 6 total, we'll be fine with the last couple, which is just whatever they decide they ask about. Velocity sometimes, they'll give you like a growth rate, like they'll give you the change in the population equation. You got to work with that. They'll give you just a function and ask you to analyze it. Okay, that's it. We have 3 days, and we're going to split our time amongst the units like this. One day, we'll focus on these problems. The next day, we'll quiz and see how you did on those. And then we'll start on the next type of problem. We'll quiz the next day, see how you did on those. And then finally, you'll worry about all the others. Okay? What you guys are doing is we'll have the review day today, the first day. We'll have another one on Wednesday. We'll have another one on Friday. But then I'm going to have you guys take your test on Tuesday. So the review day that the B-dayers get and the quiz that they have on the third free response kind of section, you're not going to get. You're just going to get 3 days and then take the AP free response test before they do so that we can have a final review day before a weekend where you can do more studying. And then the AP test is the Tuesday after that. Okay? So that's what we're going to do. Let's do it. AP free response tips. First things first, the questions aren't going to appear like you see in your packet. They're not going to be all 4 parts all at once. They're going to be split up like the intro, the first part, half a page for your work and your response. Then the second part, half a page. The third part, half a page. The fourth part, half a page. So make sure you read every single part, know what's being asked of you before you start answering certain parts. There are 3 things that will be asked for you to do. One is just to find the answer. Okay? When you see that, you should be like, sweet. Now, usually those are tough to do, but at least you know you don't have to write anything down. Just find the answer. The second thing, which we'll focus on next, is to find the answer and explain the meaning of the answer in context of the problem. If you look at 2012, number 1, everybody flip to 2012, number 1. Part A, B, and C is all find the answer and explain the meaning of your answer in context of the problem. Okay? What do I mean by that? They will say, hey, find W prime of 12. They use the calculus notation. They don't tell you what you're finding. They just say find W prime of 12 and then explain what it means. Part B, they say, hey, find the integral from 0 to 20 of W prime. You need to get the answer. And then they say, oh, explain what that means. And then part C, they say the average temperature of the water is that. But in other problems, like 2013, number 3C, 2013, 3C, it says use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1/6 integral from 0 to 6 CT. So you need to calculate that and then explain the meaning of that. What you'll have to do is calculate that correctly using their instructions and then explain, oh, this is just the calculus formula for the average C, or the average amount of coffee in the coffee maker between 0 and 6 seconds, or 0 and 6 minutes. Okay? That's what you'd have to do. So what would be good answers? Let's go back to that number 1 problem from 2012. If you're told that W is temperature and you're asked to find W prime, what would a derivative be? What would I say W prime is? I wouldn't say it's the derivative. What does the derivative mean? Yeah, it's the rate of change, the instantaneous rate of change. If it was find W prime at 12, which I think was the question, W prime of 12, you would say the change, you can say the instantaneous rate of change of the temperature when T equals 12. Right at that moment, on the end of the 12th minute or the beginning of the 12th minute, I'm not sure in that situation, it's the end of the 12th minute. No, end of the 11th minute. I don't know. Anyways, that would be it. That's how you describe a derivative. Question?
So I'm not sure if we're gonna have time problems, but let's say we are, and we're trying to write everything down. Is it alright to use stuff like IROC?
No. No. Write everything out. You can use abbreviation like INST for instantaneous, I believe, but don't write IROC out. Write instantaneous rate of. Okay, now, second one. Like the same problem. They say, what is the integral from 0 to 20 of W prime? Well, what is the meaning of that? I'll tell you right now, they're not looking for the area under W prime. That's not what they want. What do they want? Yes, the fundamental theorem of calculus states that an area under a curve is equal to the change in its antiderivative. Well, you would say this is equal to, and you would use this to calculate it, and you'd say what that is the total or the overall change in the temperature over 20 minutes. If they ask you to calculate this and then explain what it means, what would this mean? Is it the average change in temperature? Is the average rate of change of temperature? Is the average temperature? What is it? Just average temperature. This is very important. Including those couple words, like including a change, that makes it wrong. This is just the average W of T. Whatever you put in this formula, that's what you're finding the average of. If W of T is just temperature, not change in temperature, but just temperature, you're finding your average temperature, not average change in temperature. Some other things that could be asked for you to explain meanings of are like this. Maybe you have to find this using a calculator by hand. What would that be? Distance, exactly. Remember that if you have an absolute value around velocity, this is distance. We know this is the change in position, but what's another word for that? Displacement. Okay? All of these need this kind of like statement. It's a statement that's needed. It is this. Now, everybody's least favorite, but one that's not that bad, once you just practice it, is to find your answer and then justify your findings or explain the meaning, or not explain the meaning. Explain your reasoning. That's what they say. Okay? This is where people freak out. They hate writing paragraphs. They do it poorly. They lose points because they write it down. But this is when we're talking about almost like a paragraph form. What do I mean by that? Well, we'll talk about exactly what to do when asked to justify. This is my Mr. Messner's way to justify. I feel like we got a buzz going on. Am I right? Yeah, it's killing me. It's better. All right. First statement is the most important. Your intro statement is the, hey, you asked me to find this. I know what I need to do to find this. This is what I need to do. Most important statement. The work shown can be kind of not, it doesn't have to be in the paragraph. It can be on the side, but you kind of show all your work from finding your answer. And then your conclusion is based off your intro. Once you state your intro, what you need to find, you would then say, this occurs at this location, therefore it is a blank. This is the math symbol for therefore. You may use shorthand math symbols. What not to do when asked to justify. Never use it. Never say the word it. Never say it goes. Okay? And you're also not allowed to use number lines as your reasoning. You have to write out exactly what a number line would show. Okay? Now we will go over a couple of common questions when justification is needed and what you will need to show and explain. I'll start with the one that's on the previous page. Like if they ask you to find when a particle is at rest and then justify. This is what you would write. And everybody should write this, at least the first statement. You would start with your intro. You would say, I know what I need to do to find when a particle is at rest. What do I need to do? Exactly. Your first statement would be a particle is at rest when its velocity is 0. There's your intro. That is showing the test readers that you know what you're talking about. You know what you need to find. Okay? Boom. You then do your work. You can do it on the side. You set, some velocity function equal to 0. You solve for a value. You find t equals 4. Okay? You would say this occurs at t equals 4. Therefore, that is when the particle is at rest. Yes. Yes. You can say v of t equals 0. Okay? Next things. Relative maxes and mins, absolute maxes and mins, inflection points. You would need to have very solid intro statements. Relative maxes and mins. Let's say we're looking for a relative max. Your first statement would be a function has a relative max when the sign of its derivative changes from positive to negative. If you can write that down, the people reading your test is like, okay, this guy knows what he's doing. This gal knows what they're doing. You do your work, say you set the thing equal to 0, you then figure out you got this number line. What you can't do is just like point here. You would have to say this occurs at x equals 2. Therefore, that is the location of your relative max.
So in parentheses, that's the work that you would choose?
Yep. And that's completely fine. But if you don't write your intro statement, if you would say, we have a max at x equals 2 because of this, that would not be correct. You'd have to have the, hey, I have a relative max when the sign of f prime changes from positive to negative. Absolute max. What?
If you do positive and then like plus minus for positive and negative.
Just write that down. Write down positive to negative. Absolute max and min. Don't forget, if you're trying to find an absolute maximum value, okay, it's not going to necessarily be at the locations of your relative maxes and mins. You need to check your relative maxes and mins and your endpoints. So your intro statement, so that the people who are reading your test know what you're doing and know that they know that you know what you're doing, is you would say an absolute, say, min occurs either at the location of a relative min or at an endpoint. You might have to say there is a relative min at x equals 3 since the sign of f prime changes from negative to positive. And then you would compare f of 0, f of 3, and f of 8. You would say absolute min must be at f of 8 because that produces the least value of the 3 possibilities or the 4 possibilities. And that's fine. Just make sure you check it. Inflection points, you need to show that the second derivative changes sign. So you would write, hey, justify your findings to find an inflection point for f. You'd say f has a point of inflection where f double prime changes sign. And then you would do your work. You'd figure out when f double prime changes sign. And then you'd say this occurs at this location. Therefore, is the location of an inflection point. Okay? It has to change sign. Has to. And it doesn't have to be f. It could be something has an point of inflection when the sign of its second derivative changes. Okay? Continuity. If you're asked to show that something is continuous, I've seen continuity questions every once in a while on the AP free response. Well, you need to know the definition of being continuous to be able to answer things correctly. If you don't know the definition of continuity, you're not going to get it right. You'd have to say f is continuous at this value if the limit as x approaches the value equals the function value at that location. So what you would have to do to check is you'd have to find the limit as x approaches that value from the left, the limit as approaches the value from the right, and find the function value. Check all those 3 things. Once you have that, boom, you have your justification. You can say it's continuous. But it's all about that intro statement. Before you even do any work, you say, boom, a function is continuous when this occurs. A function has a relative max when this occurs. A function has an inflection point when this occurs. And then don't forget the 2 theorems, the intermediate value theorem and the mean value theorem. Intermediate value theorem, function must be continuous. And it's all about function values. It has nothing to do with derivatives and slopes of derivatives. The mean value theorem will be your method to prove that a derivative must exist. Function must be continuous and differentiable. And we would say that if it is continuous and differentiable, there's some location between these 2 points where the slope of the tangent equals the slope of the secant, which is here. And this has to be between A and B. and here's my C. So let's look at, what's the first problem you have to do for homework? Like a table problem. So number 3, part B. The question is there a time between t equals 2 and 4 at which c prime of t equals 2? Justify your answer. You need to use the mean value theorem for that. This is 2013 3B. Is there a time at which the derivative of c equals 2? Well, guess what? If you found the slope between t equals 2 and t equals 4, you'd find the slope between those 2 points is 2. Since the slope between those 2 points is 2, and since you are told that the function is twice differentiable, that means it's continuous and differentiable, then the mean value theorem applies. You'd say since the slope of the secant is 2, there must be some location between 2 and 4 such that the derivative at the locations equals that slope. Mean value theorem 3B. Got it? Great. And that's really it. The one thing I would also warn you about is when you're dealing with an accumulation function and providing connections. Make sure we provide connections. So say you're given that g of x is equal to the accumulated area from 0 to x of f. You're asked, when does g have a relative min? Well, you would state this: g has a relative min when g prime changes sign from negative to positive. Well, the connection is that g prime is equal to what? Yes, f of x. Not t, but x. You'd say, okay, since g prime equals f, we can analyze when f changes sign. This occurs at this location. Therefore, that is the location where g has a relative min. This right here is the connection between what we have and what we're looking for. Make sure you include that. We did that back in Unit 8 when we dealt with accumulation functions. That's all I got. That's all I got to prepare you for. Conclusions. Free response. Yes, intimidating. You only have 6 problems and it's worth half of the entire test. However, there are consistencies in the types of problems that are going to be asked. If you're familiar with those last 4 units, you can pretty much be assured that you're going to see at least 3 of those problems, okay? So be comfortable with those 4 units and those problems in the units. The rest of them could be anything, but we're going to do the last 10 years of AP free response questions. You will have seen pretty much everything, okay? So you're ready for the types of problems you're going to see. That's the first thing. The types of questions that are going to be asked, remember, it could be find an answer and show your computations, find an answer and explain the meaning of the answer, or find an answer and justify your findings, okay? 1, great, just get you your answer. 2, explain what it means, quick statement. 3, make sure you have your intro, your work, and your conclusion, and you're good. We will start for the rest of class by starting on your homework. Your homework is what? I think it's the Unit 7, Unit 8 stuff. Yeah, Unit 7, Unit 8. So I gave the wrong problems to the last class. You guys are working on these problems. Those are your homework. We're going to do these for homework, and during class, we'll go over them. Any questions you have for them next class, I will then give you I'll give you a quiz One problem is going to be from this unit. One problem is going to be from that unit. We'll be able to grade and see how you did on something that's fresh and just looks new. The answers to all these questions are online. Feel free to use them, but don't rely on them. Don't think that, oh, I'm just going to copy them down and then I'll go for my quiz and see how I did, because that's not how you're going to prepare yourself.